Hey everyone, so somehow I missed this video and I'm glad I noticed. So I know it's the middle of October and this is way long ago, but here's your systems by substitution video. Now with graphing really only worked if you had y equals and y equals, we plug in the calculator. With substitution, as long as you have either y equals or x equals, if you have at least one of them, or if you can get to one of them very easily, substitution is really the way to go. I'm actually going to hold this up here. So what we started with is, hey, do we remember how to solve an equation, like a multi-step equation? And so we move the constant over by add or subtract, then we divide. So it's just a little bit of practice doing that. Substitution works this way. I have y equals negative 2x minus 9. Well, if you're telling me y equals this, then this y right here also equals this. So we're going to take this negative 2x minus 9, and substitute it in for the y, which is now 6x minus 5, negative 2x minus 9. It did say minus 5y, but y got subbed with what y equals negative 19. We solve the equation and get a variable, or get a value for x, because we only have x left. So we can solve for one variable. Take x, plug it in right here, find y, get an answer. Now again, with systems, we're trying to find this xy point where these lines cross. So we need to make sure we have both an x and a y, and then we put our answer kind of in an xy point for our final form. So as soon as we get y equals, we can take that and sub it into the other y, distribute, combine like terms, move the constant, divide, get an answer, plug back in, get the other answer, and it's done. I'm trying to remember where this came from. It'll probably pop up here in a second. So here's another one. We take this negative x plus 3 and we plug it into this y right here. So 3y now says 3 negative 3x plus 3. Distribute, combine like terms, find an answer. Then we plug back in, but you got to be careful. We're plugging back in, let's see, what did I get? Y equals 8. This should probably be over here. We're taking this and we're plugging it back in over here. So oh, you know what? I'm going the wrong way. Distribute, combine like terms, and I actually went up here because 5 minus 3 gets me 2. So we solve for x. We get x first. Then we plug x back in. Okay, that makes a lot more sense. I'm sorry. Plug x back in. And we got to be careful because we're really only substituting this x. X equals negative 5. So this equals negative 5. If there's anything in front, that still has to be there when we take the negative 5 and plug it in. So negative 5 is actually positive 5 plus 3, and we get 8. We could actually take the negative 5 and plug it into the other equation also. It doesn't matter. That becomes negative 25 and add it over and then divide. So it's the same thing. So here's our next example, and on this one we actually have y equals and y equals, which normally we'd be like, this is great, let's graph. But really with substitution, due to substitution, if they both equal y, then they both equal each other. So let's get them to equal each other. Solve, plug back in somewhere. It doesn't even matter. I think we chose... Oh, let me show you what not to do over here. Oh, we plug back into the bottom because negative 2 times negative 4 is 8. And then, you know what? I need negative 2, comma, 8. Now, here's what I don't want you to do. This is what happens over here. Set it up, and like we move this. Oh, because we chose to move this over here and had the variables together that way. If you move the variable over here, that's fine. The problem is I see a lot of this where add 4x and then I get 7x and 14. They lose track of the equal sign. They're like, well, how'd the equal sign move over here? Really, that's supposed to be the plus sign. It should be 7x plus 14 equals 0 because that equals 0. Once you do that, you get the same thing. But here in red, originally, obviously x is not 2. It's supposed to be negative 2. So 7x plus 14, you subtract, here we go, subtract the 14 over and then divide, and then we finally get the right answer. So please make sure if you're going to move this over, you know that there's a 0 on that side. We have fractions here, not a big deal, because we're going to take this and plug it in, and we distribute the 2. Well, half of 2 is 1, and negative 1 times 2, and combine like terms and solve, and we do get a fraction. Well, that's kind of weird. Well, let's plug it in. Why not? Plug it in. Where do we plug it in? To this bottom one. So 1/2 and 1/2 minus 1. So 1/2 times 1/2 is 1/4 minus 1 is y equals negative 3/4, which is really weird. And we got a fraction. How do I know if it's right? Well, if this equals 1/2, and then you plug in for here and get it to equal 0, which 3/2, and then that ends up being negative 3/2. Those cancel out to be 0. It ends up working. Fractions are going to happen because, like I said back here, like they're not always going to cross at nice, pretty points. Like that could be a fraction xy point, and there's really no telling what it is. You just got to plug it back into both equations and make sure. To get a fraction in your calculator, hit alpha y equals, had that up on the slide. And that was day 1.